In this video, I will be showing you all how to use SAP2 assembler to assemble your SAP2 code. So the SAP2 is an architect, it's a computer architecture. So if you were making one like on breadboards like I'm doing, I have a series on it. If you are doing that, then you would need some way to assemble the code. So I've made a Python package called SAP2 assembler like this. And if you use this, you can just write SAP ASM files and you can assemble them into byte code or yeah, into bytes, normal just bytes. To get started, I'm going to create a main.py file and then I'll just open it. And then now what we can do is I'm going to do pip install SAP2 assembler. And then while that's installing, I'm just going to write, you can just do pip or you can do import. And then we're going to import SAP2 assembler. So now if we run this just to check if everything's okay, you can see we don't have any errors. So now instead of import SAP2 assembler, we're going to say from SAP2 assembler, import SAP2 assembler. And then we're going to define our assembler instance or object, whatever you want to call it. So we're going to say assembler equals SAP2 assembler like this. And then we can say assembler dot assemble. So this will take text. So there's another function where you can even do it from a file. We'll get to that later. So now, for now, so you have some opcodes here. Not opcodes. You have a lot of mnemonics here. I think it's 40 or 33 or something like that in the SAP2. So you have the, let's just do move A to B. Just that's all. So we're going to take whatever's in the A register and move it into the B register. It's not going to actually, it's not going to run on my laptop here, but it's going to compile that code or it's going to assemble that code and it's going to give me an output. And then file to write, we'll just say print output. We're not going to write for now. We'll just say print output equals true. So now we'll print the assembled bytes. So now if you want to say python main.py, you can see by default it prints 256 bytes. I'm going to show you how to change that. So you can see the opcode for move A into B apparently it's 78 in hex, which would be just 78. So now if you want to print less bytes, right now it took by default it prints 256 bytes. Not just prints, it outputs 256 bytes. So let's actually write to a file. So file to write equals, let's say assemble code dot this is make a txt file. So now if we were to run this, it will generate a new assemble code.txt file and it has just basically kind of copy pasted this output into here. Not exactly copy pasted, but the same thing. And then let's actually change the number of bytes. So instead of printing 256 bytes, we can say n bytes equals, let's say we want to print just 64. So now if I run this, it'll output 64 bytes and here it will also write 64 bytes to the file. And then now let's say I want to, currently this is in hex, right, because it's 78 which is hex. So let's say I want to do binary, so I can say hex output equals false. So by default it's true because then you won't see, like if it's in binary it'll be 8 numbers per address, so it'll be very long. So by default it's in hex. So now if I run this, you can see it's in binary. So that's the output. And then there's also one more thing called row. So the row basically here, I'll show here, you have you have 8 addresses per row. As you can see, it starts at address 00 and the next row is address 0008 or just 8. And then the next one is 0010. So it's incrementing by 8. It's incremented by 8. So if we want to change that, let's say we want 16, we want it to increment by 16, or we want the row width to be 16, otherwise you can call it. So now the row width will be 16. I'll just change this to um, false, or yeah, I'll change it to true so that it doesn't occupy much space in the terminal here. So now we have that working. And so now let's create an SAP2 ASM file, which is an SAP2 assembly file. So let's name it like assembly code.sap2 asm, just like this. And then here, I'll show you the syntax for everything. So if you want, you can. I also have syntax highlighting and auto completion in my IDE for SAP2 ASM files, but you won't obviously get it from the package. So if I were to say move A comma B, this is move A into B. Well, sometimes syntax highlighting doesn't work, but it's still the package will still parse this. So move A into B is just a single byte. As you can see here, we did move A into B and it's just 7, 8. So if we were to do multi-byte instructions, what we can do is, let's say we want to do LDA, which is load A. So we want to load A basically takes an address, and it will look whatever content is in memory at that address. It will look at the contents of memory and it will write that into the A register. So if we want to, this will take obviously 4 bits, or yeah, 4 hexadecimal bits, whatever you call them. So because SAP2 has a 16-bit address space, address register. So if you're representing it in hexadecimal, it'll be 4 digits. And if you want to specify the whatever operand in hex, you'll add a dollar and then you can specify the operand. So I'm just going to do 000F. So if I run this now, or no, we have to here. Let's just comment out this line for now. And then we'll say assembler dot assemble, or we'll say assemble from file. So now it will read the file so that you don't have to read it manually. So the file will be assembly code.sap2asm, and then the file to write will be our assemble code.txt. So now if we were to run this, it will not print anything because print is false by default. So you can see, yeah, here the SAP2, I'm pretty sure it's little endian format. So the low byte is first. So you can see the opcode for LDA is 3A, and then usually, because here I did 000F, but it's little endian format for the SAP2 at least. So it will be the low byte first and then the high byte. That's why it's 0F00. So now if I were to add, let's say I had, um, let's say I say move immediate A. Move immediate A, basically this LDA will take an address as an operand. Move immediate A, it just takes the immediate value. So you can say move 0F like this. Now if we go here, obviously you don't have to write it to a file, you can print it again. So now we have 3A, which is the opcode for load A, and then it's leaving a byte here because again the LDA opcode is in little endian format. Well, the operand for it is in little endian format. So you have the low byte and then the high byte, which is 00 as we specified here. And then move immediate A is 3E, and then it's again, no, it's not, it's just one, it's a 1 byte parameter, which would mean you just have 0F. If I change this to 05, it would update there like this. Now if I wanted to specify in binary, so let's say if I want to specify in binary, I have to use the hashtag symbol. So let's say I want to do just this. So if you typed more than 8 bits, then it will give you an error like let's say I just do this, it will say operand must be 1 byte. But if I type less than it, it will auto fill it. It'll make it 8 bytes. It'll just add zeros at the end. So if I were to do this, this will run, and then so this is 6 bytes. I mean 6 bits. So the remaining 6 bits will automatically be filled in as zeros. So you can see here we have 1 5, which is apparently this. Well, yeah, this part is 5 0 1 0 1 is 5, and then there are two zeros, which means 2 0 plus 1 will be three zeros, and then a 1 at the end, so it's 1 5 when you convert it to hex. And obviously, if we were to do it in binary, it you will show you'll see the exact same thing here. Yeah, so you can see the exact same thing here with here. This is exactly what we typed in the SAP2 SM file. So that's for multi-byte instructions. Or yeah, and you can obviously do, like I said in the first example, you can move A into B. Those don't require operands. But if you didn't specify an operand, it would tell you takes an operand, but none were given. And yeah, it'll tell you the line number also. Well, I have relative lines on. So it says line 2. So it starts from 0, 1, 2. Well, in the code. It starts from 0, 1, and 2. I have relative numbers on, so it's kind of confusing. But yeah, so if this were line C, so you start at the top, and this take this as line 0, and then instead of starting at line 1, just take it as line 0, and then you can figure out where the error is exactly. And then now if I want to say I want to define a macro. So what a macro is, or let's first go to labels. So label is just basically a marker of like an address. So if I were to say I have a label here, just a label, the name of your label and colon. That's all. Just for the syntax. Now in the label, if I were to do LDA 00F0, and then if I were to do jump also works. So jump will take again a 4 bit, yeah, 4 hexadecimal digits or for 16 binary bits. So if I were to say 0040, now if you were to run this on the SAP2, this would still run. It's not like a function. You're not defining a function here. It would still run. But let's say now I have some other stuff here. Let's say I do some other stuff. So let's say I do some other stuff here, and then I want to go back to this label. Now, obviously, I can just do jump and address 0000. This will work because by default, obviously, it's at address 0000. This label doesn't occupy any bytes because that's just for the assembler. So if I were to run this, you can see what's happening here. LDA 00F0. That's going here LDA 00F0. And then you have jump 0040. So jump 0040. And then you have another jump at the end here. You have jump 0000, which is what I added here. So now let's say I have some other stuff up here. Let's say I do LDA, let's do 05. So it will fill in the rest, it will become 0005. So if I were to do that, oh, well, I guess I'll have to fix that in the latest version. Anyways, so if you were to do that, then now you have another instruction here. So you have LDA 0005 or 0500. But so over here, instead of label, If I were to say it's a loop, which I'm just calling it a loop, it doesn't have any special meaning in the assembler. So over here, instead of, we just remove this line. And then if I were to say I want to jump to address 0000, so that will go here. But if I want to jump to this loop, you can see this, this mnemonic or this whatever instruction you want to call it, it takes 3 bytes, right? Because LDA or the opcode is 1 byte, and then the operand is 2 bytes. So you really want to jump to address 0003. This will jump back to the loop. Yeah, you can see here we have LDA 0500, and then you have the loop stuff over here. You have that you have LDA 0, you have LDA 000F0, and then over here you have a jump to address 0003. That's what is a jump 0003. But now if I were to add some code here, if I were to add some code over here, like let's say I'll just add another LDA here. So now this output is wrong, or well, the jump is wrong, because now if I want to jump back to the loop and restart, just stay in a while true loop kind of, it will actually go up here. It will execute this LDA 50500 instruction. So now again I have to come over here and have to update it. So 3 plus 3 will be 6 bytes. But let's say I want it to be dynamic. Then I can just do jump loop. So I can jump back here to the loop and it will automatically, it's a 2 pass assembler, so it will first detect all the labels and stuff like that, and then it will fill in for those. So wherever loop is there, it will put address of wherever loop is. So now if I run this, you will see here we have a jump, or no, it's this one, jump 0006, which is what the address would have been, because this takes 3 bytes, this takes 3 bytes, and this starts at 0006. So we can dynamically jump to some random label, which you can have multiple labels obviously. And now if we were to say, let's just delete all this. Now there's something called a macro. So for a macro, you can say dot macro. And what you can do is you can just define a macro. So let's say the macro name is test. So the syntax is dot macro space the name of, well, your macro. And then whatever is inside this dot macro block, that will be part of the macro. So now if I were to say LDA 00F0 and then jump, let's say I were to jump to 0404, and then I were to jump, and then let's say I move A into B. Now I have to specify the end of the macro. I have to say dot end macro, like this. So now if I run this, there won't be anything in the bytecode. You can see they're all zeros. But if I call test, now it will fill in wherever. So test was called at 00 address, all zeros, because this doesn't take anything in the byte. It doesn't take up anything in memory. So the test is at 0000. So wherever I call test, it will fill all this in. So it will actually replace the whatever name. So if I call test, it will replace that, and it will delete this and it will replace it with this. So you can define multiple macros obviously, and yeah, stuff like that. And then now if I were to say .org, let's say I don't want, if I call test, I don't want it to start at 0000. Let's say I want it to start at this 0008. So what I can do is I can specify .org, so origin. Again, this can be binary or it can be hexadecimal. So let's say I want to start at 000F. If I run this, you can see it starts here. Yeah, it starts here because, yeah, this is 000F, this is 0008, and then you continue here and it starts at address 000F, and then it just continues from there. Again, after here, I can obviously say, I can say dot or address 0000, and then I can call test again, and it will fill in there. So it starts here. This is the second time we called it, and then this is the first time we called it. And then next, after .org, you can obviously just set the origin of where you want the next block of code to go. So that was macros. Now you have a .word. So .word is just, well, it will write a 2-byte word into wherever, whichever address it's at. So if I were to say hexadecimal 0f0f, so it starts at either 0000. So you can see here we have 0f0f. It's in this is also in little endian format. So if I were to say 0e this time, first it'll become 0e and then it'll be 0f. So that's dot word. And then you have dot byte. So for that it's just a single byte, as you can infer from the name, just like that. And then you have a dot ASCII. You can specify a string here. And let's say I want to say hello world. So if I were to run this, it will parse that whatever the ASCII value for all of these letters are, and it will write that into the file like this. And then finally we have dot include. So we can go ahead and create a new file. We can say type null. Uh, we'll just create helper dot sap2assembler like this. And then over here we can define macro, or you can do whatever you want. So if let's define a macro helper one, and then let's say LDA 000F, and then we'll say move A into B, and then we'll say move B into C. So now we've stored we whatever is in memory at address 000F, we put that into the A register in this line, and then from the A register we move that to the B register, and from the B register we move that to the C register. So basically all the registers, the values of all of them are the contents in address 000F, and then obviously we have to specify .end macro. So now over here in this assembly code.sap2asm, we can do include just like this, and then it's dot include, and then you have to do angle brackets or less than, whatever you want to call it, and then we specify helper dot sap2asm. So this should not give us any errors. Yeah, and you can see there's nothing in memory or there's nothing in the output. Now if we were to say let's say we call the helper, let's call the helper one macro, or not call it, we'll just kind of call it basically. And then you have, so whatever this is, it's basically just including the code from this file into this file. That's all. And then you can obviously have recursive includes. So like from here I can include another file, and then from that file I can include another file, stuff like that. But if you include the same, so from assembly code.sap2asm, I'm including helper.sap2asm, and from helper, if I were to include assembly code.sap2asm, then it's just going to sit in a while through loop, and it's not going to do anything. You can see I have no output. If I were to press Control C, then it would register the keyboard interrupt and stuff like that. Obviously, you can also define labels here. So I'll say label, and then we'll LDA. You can use indentation, whatever you want. This LDA 0 F0F. So now it will actually give me an error, or I have to actually remove this line. Now it will give me an error, or well, so I have to fix that too. So it will not give me an error for some reason. But anyways, so now we can define a label here. LDA0F0F, and it will write LDA0F0F here. And obviously we can, in the assembly code, we can delete this and we can say jump to a label. And then after that, it will also do a jump to 00. So yeah, you have jump and then add the 0000. So that's it for this video. In the next video, I'll be continuing the RL from scratch series. But if you like this video, then I have my own channel. I'll put it somewhere over here where I have, as you just heard, an RL from scratch in Python series and some other videos. So if you're interested, if you like this video, then you should probably check out my channel. But yeah, that's it for this video. Okay, bye.